Okay, this is the section 3 homework. It's the first problem. It gives us a formula for Fahrenheit related to Celsius, and then it tells us that if the temperature is 23 degrees Celsius, what would be the corresponding Fahrenheit temperature? That's pretty easy. Just plug 23 in this equation. 9/5 times 23 plus 32 should give you 73.4. Okay, the next problem is it gives us a point and it gives us a line. It wants us to find the distance from the point to the line. This is one that helps to graph so you can see it. The line has a y-intercept of -1 and a slope of -2, which means it goes down 2 over 1, down 2 over 1, like this. So I can go back this way if I go back 1 up 2. But that's the line. And then the point is this blue point right here, 0, 1. So we're trying to find the distance, this green distance right here, from that blue point to that red line. The best way to do it is to write an equation for this green line, which we know the slope of the green line has got to be opposite reciprocal to the red line. The red line has a slope of -2, so the green line needs to have a slope of 1/2. So it's y equals mx plus b. And we also know the y-intercept of the green line is 1. So there's our equation for the green line. The red line, they gave us the equation for that right here, which is y equals -2x minus 1. So the best way to solve this is to just set them equal. Here's our system of equations that we're solving to find the intersection point right here. And if we set them equal, we get 1/2 x plus 1 equals -2x minus 1. And then we can subtract 1/2 x from both sides and add 1 to both sides. That's 2 equals -2.5 x, or 2 plus 1/2 would be let's see, over 2, so 4 over 2 would be 5 over 2, obviously. 5 over 2x. Multiply both sides by 2. And you get 4 equals 5x, and then divide both sides by 5. So x equals 4/5 is the x coordinate. And I'm not sure what they want for this problem. The distance, so we need to find the distance from this point, which we have the coordinates for now, 4/5, comma. We need to find the corresponding y coordinate. So I'm going to plug this back into either one of these equations to find the corresponding y coordinate. I'll do the first one. 4/5 times 1/2 is 4 over 10 plus 1. So we have 4 over 10 plus 1, which is multiply top and bottom by 10. That's 14 over 10, which simplifies to 7 over 5. So 7 over 5. So there's the coordinates of this point right here. And I need to find the distance from that to the point 0, 1. So to do that, I'm going to use the distance formula. The distance formula is the difference of the y, so I have 1 minus 7/5 squared, plus the difference of the x is 0 minus 4/5 squared, all square rooted. So I'll make a common denominator, make this 5 over 5. This is obviously just going to be -4/5. So this is -2 over 5. When you square it, you get 4 over 25. Plus, and when you square this one, you get 16 over 25. And that's all square rooted, so that's 20 over 25. The square root of 20 over 25 is the distance between the 2 points. Now, I might be able to reduce this sum or simplify it some. Let's see. 4 times 5 over, the square root of 25 is just 5, so I can evaluate the square root of the bottom as 5, and then break up 20 as 4 times 5, so the square root of 4 is 2, so it's 2 square root of 5 over 5. So it'd probably accept either one of these answers, but let's try them real quick. Yeah, square root of 20 over 25 works fine. Okay, the next problem is problem 3. It says it takes you 8 hours to dig a hole. It would take you and your brother 5 hours to dig the same hole together. If your brother was to dig the hole by himself, it would take him how many hours? Okay, so I'm going to do this as a rate. So you can dig one hole in 8 hours. So here's you. All right, and now plus, we don't know your brother's rate to dig the hole per hour. And you can reciprocate this. It might even be easier to reciprocate it, but I'll do it like this. So this is your brother. And together, you guys, it takes you, you dig one hole in 5 hours. So you plus your brother working together, you can dig one hole in 5 hours. Now I could have easily flipped these fractions and did 8, you know, and then this would be 1 over x instead of x over 1. But I'll do it like this. So I'm just basically solving this. So I have x equals, I need to subtract 1/8 from both sides. So all I need is 1/5 minus 1/8. So I need the common denominator to multiply the top and the bottom of this one by 8. The top and bottom of this one by 5. And that gives me 3 over 40. Now keep in mind that gives me holes per hour. So holes per hour, and that's not what they wanted. They wanted to know how many hours it takes to dig a hole. So I need to reciprocate this. So I want 40 over 3, and that's hours per hole, which is what they asked for, which you can enter in as 13.3 repeating if you want. Okay, this is the next problem, problem 4. It says you wish to invest $1,400 over 1 year in 2 accounts paying 5% and 6% per year. How much did you invest in each to earn $79? You're going to set up a system of equations for this. I'll call X how much you're going to put in the 5% account, and I'll call Y how much you're going to put in the 6% account. And that's got a total of $1,400 because that's how much you're investing total. So that's just the total equation. Then the interest equation would be 5% of the amount you put in account X plus 6% of the amount you put in account Y has to equal the interest that you gained, $79. So you're solving this system of equations. And to solve a system, you just subtract X from both sides, for example, and substitute. That would work fine. So you'd have 0.05X plus 0.06 times 1,400 minus X equals 79. Now you just distribute and solve this linear equation, which you guys can handle. When you do that, you get X equals 500 and Y equals then 900. That's total 1,400. So that's 500 in the 5% account and 900 in the 6% account. Okay, the next problem is problem 5. It says an apartment building sold for $185,000 6 years after it was purchased. So they basically gave us an order pair, 6, 185,000. This is a linear relationship. We know linear relationships have the equation y equals mx plus b. They also give us the slope. They say that it appreciates 2,000 per year. So it's going to gain 2,000 per year. That's the slope. So I'm going to fill this out. I'm going to plug in, for x, I'll plug in 6. And for y, I'll plug in the final amount, 185,000. And I'll solve for the y-intercept because that's what they want. They want the equation. They want us to put this in with m and b. So if I do this and solve for b, I get 173,000, which is the original starting amount of the house. So the equation for the house is y equals 2,000 x plus 173,000. So basically the house value started off at 173,000, gained 2,000 per year. Slope and y-intercept. Okay, so the next problem then, it says you have 3 tests. You have an 88, 78, and another 88. And you're going to take a 4th test, and you need to average to get an 80% in the class. So I'm going to do these as percentages. Now, I'm going to do the second one twice because it's worth twice as much. There's different ways to do this, but this is the way I would do it. And divide by the total, then there'd be 5 tests. Okay, so if you did that, and you solve for, you got to multiply both sides by 5 and subtract these numbers over, and then divide by 2 from these 2 quantities right here, you'll end up getting x equals 0.73. I tried entering that in, it didn't work, but that's because they wanted the total out of the points. So this one was worth 200 points. If you multiply by 200, it'd be 146 out of 200, would give you the 73. So 146 is what they wanted you to enter in right here. Okay, the next problem says you're driving at an average speed of 60 miles per hour from city A to city B. So there's city A, there's city B. So you're driving 60 miles per hour. And then you're going to stay in city B for 10 hours. And you're going to come back at 60 miles per hour. The total time is 41 hours. How many miles is the question? So what's the distance? All right, so we know that velocity equals distance over time. So multiply both sides by time, and you get distance equals velocity times time. That's what we're going to use for our equation. So we know the velocity that we're traveling with is 60 miles per hour in this case. The time is, we're driving for 31 hours if we were stopped for 10. So that gives us 1860. But the problem with that is that's there and back. We only want the distance there, so we're going to have to divide that by 2. And that gives us our answer in our case of 930. Let's try this problem again, but let's do it with different speeds because a lot of your guys' problems has different speeds. Mine's the same, so it's very different. So let's go from A to B, city A to city B. On the way there, let's say we're going 40 miles an hour. And on the way back, let's say we're going 55 miles per hour. Okay, the time total is 41 hours. We're still going to stop for 10 hours. Let's say. Actually, let's say we're going, the total time is 43 hours, and we're going to stop for 10 hours here. So that leaves us with a total driving time of 33 hours. So this would be driving time. Okay, I'm going to have to set up two equations for this because they're different on the way there and the way back. So I'll set up an equation from A to B. From A to B, we have distance equals velocity times time again. The velocity is 40. We'll call the distance d from here to here. And the time then, let's just use t for that. We don't know what that time is to go from A to B yet, so we'll just call it t. Now let's set up an equation for going back from B to A, city B to city A. Distance equals velocity times time again. The d, we'll use the same d because it's the same distance. The velocity now is 55, and the time, we're going to have to do what's left over, so it'll be 33 minus t. Because that's how much time is left over from the 33 hours of driving time. So here's our two equations right here and right here now. We have to solve that system by setting them equal to one another. So we have 40t equals 55 times 33 minus t. And then we can solve this by distributing. And that gives us 1815 minus 55t equals 40t. And then obviously just add 55 to both sides. That gives you 95t equals 1815. If you solve for t by dividing both sides by 95, you get t equals 19.1 seconds. I'm going to keep that in my calculator because they didn't ask for time on the way there. This is time on the way there because it solves this t right there. So that's time on the way there, but they asked for distance. So I'm going to take time on the way there times 40 to get the distance. You multiply it by 40, that gives you 764 miles, 764.2 for the distance on the way there, which is the same as on the way back. Okay, so next equation is 8. We got to set up two equations. It says a cash register contains $10 bills and $20 bills. Right when I see that, I'm going to define two variables. I'm going to call x the number of $10 bills, and I'm going to call y the number of $20 bills. That's really important, defining variables, because we're going to set up two equations. It says the cash register contains 5 times as many $10 bills as 20. So that means 5 times the number of $20 bills gives you the number of $10 bills. There's one equation. The next equation is for total amount of money. We know that the number of $10 bills, which would be x times $10, plus the number of $20 bills, y times 20 would give you the total amount of money in the cash register. So the number of $20 bills times $20, plus the number of $10 bills times $10 gives you the total money. So those are the two systems we're solving. And I would solve with substitution. So I plug this in, 10 times 5y plus 20y equals 2,450. And then solve this for y, which you guys can handle. When you do that, I think you end up getting 35 for mine. And when you plug it back into this equation right here for y, you'll get 10 times or 5 times that amount will give you the number of $10 bills, which is 175, and that's the answer they want. They want the number of $10 bills.